Hello and welcome to another episode of Skolaris Weekly. I'm your host, Martin Klemsa. This time we're not going to be solving timetables, but a different optimization problem. People don't realize that Skolaris is actually a universal tool for optimizing NP-complete problems, and one of them is a popular puzzle game called Sudoku. So let's see if Skolaris can solve Sudoku for us. So I've created an organization called Sudoku and a term called Sudoku. And in case you don't know what Sudoku is, it's basically a problem of fitting 81 numbers, each 1 to 9, to a matrix 9 by 9 following certain rules or constraints. And we're going to try to configure Skolaris so that it satisfies these constraints. But let's create our matrix first. So it's going to be 9 by 9. There we go. And we're just gonna use the letters for the names of the days so that we know that this is not a timetable but something else. So we've got our A to J 9 rows, and we've got columns 1 to 9, but here we're gonna delete those times. There, our board is set. We're going to use just one class group for this, and we're going to call it Sudoku. And the goal will be for this class group to have 81 lessons that will fit in that matrix we've just set up. The subjects will be the numbers in the Sudoku matrix, which is 1 to 9. So let's create 9 subjects. Very good. And we're going to need 9 lessons for our class group for each of the subjects. So let's create 9 instances, and the teaching group will always be the same. And we're not going to assign teachers just yet, but we will need them later for implementing some of the constraints. Excellent. Our class group has 81 lessons. Let's create an early timetable. Create an empty timetable. And this is going to be draft 1. What organization data is invalid? What's wrong with organization data? Maximum periods per day. Yes. We haven't configured our term or class group correctly. So let's do that now. So we're gonna need to start in period 1. And we're gonna need 9 lessons per day, no gaps, no lunch. And save that. Our errors are gone, and let's see what Skolaris does on our first run. So what did it do? If we examine the rows, we will find that the numbers do not repeat, which is actually the first rule of Sudoku. In each row, every number has to appear exactly once. How is it possible that Skolaris knows that? Well, it doesn't know that, but it knows that when there are 9 subjects with 9 lessons each, it should put them in different days, distribute them throughout the week. So that's what happened here. We're not going to show breaks, which will make it more compact. And yeah, I think like this it looks good. So in each row, each number appears exactly once. In Sudoku, this has to be true about all columns as well. But there is no such constraint in Skolaris directly. So how are we going to do that? For this, we're going to need to assign teachers. Specifically, we're going to use one teacher for each subject. So let's name them the same as the subjects. Let's also assign them to the lessons. So these 9 lessons will be taught by teacher 1. And these 9 lessons will be taught by teacher 2. And so on. Now that is done. Let's configure our teachers. So these guys will have 1 lesson per day with no gaps. That's good. But we also need to specify that in each of the periods they can teach only once throughout the whole week. And we'll need time fields for that. So we're going to create 9 time fields for each column. So this will be column 1. Column 2. Good. And let's also configure the time field limits. Right here. I'm going to say cluster busy times, and we're going to add all these columns. So we're basically going to say that the teacher has to use all these time fields. And because the teacher teaches 9 lessons, it will mean that there will be 1 lesson per time field or per column, because we've created these time fields as our columns. And this is a requirement. Let's head to our draft and see what's going on. One more thing we're going to do. Let's actually create a new configuration set for constraints. And let's turn off all constraints. So that's all constraints turned off. And now we want to see the essentials and turn some of them on. So a lesson has to be booked. A subgroup cannot be double booked. Teacher cannot be double booked. Okay, teaching limits, cluster busy times. We're going to turn this on. And also schedule balance, course, daily booking, turn this on. Right, so if I run this, the result should be a matrix where each number appears in exactly one row. Sorry, each number appears in all rows exactly once, and also in all columns. So let's watch. For example, there's 2 3s, 2 5s, and 2 7s in the first column at the moment. We're done. So yeah, that looks good. But that is not the complete set of constraints for Sudoku. There are more. Let's do one more slightly complicated one, which says that in each quadrant, let's say, or 3 by 3 submatrix in the top left and middle left and bottom left, each number has to appear exactly once. Yeah, you guessed right. We're going to use time fields for that. So let us create those time fields. So this is going to be top left. Middle left. And bottom right. So what shall we do with them? Basically, we're gonna try to do this very simply in the same way that we utilize these columns. And that is by saying that each teacher has to teach in all of those time fields. And that theoretically that should be enough, but it hasn't been tried before, so let's just try it out. Bottom and middle and top. Yeah, and use all of them required. See if that helps. 39%, yeah. Look at that. Let's run this. That was quick. Let's check our quadrants to see. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that worked. That worked wonderfully. Brilliant. But this is still not a valid Sudoku. One more constraint in Sudoku rules says that on the two diagonals, each number has to appear exactly once. Let's check the main diagonal here. And this will have 2 7s, 2 8s, so that doesn't hold. 3 8s even. So let's create two time fields for these diagonals. So it's going to be like diagonal 1. And let's choose all of them. And diagonal 2. Perfect. Now how to specify? There has to be one number. That each number has to be represented on the on the diagonals. This is not immediately obvious how to do this, but I think it's going to be sufficient to say that each teacher can only use one of the particular diagonal, because each teacher can teach only once on each of the two diagonals, and that would mean limit busy times. So if I add diagonal 1 and say that a maximum of 1 period is allowed from this time field, this will apply to each teacher, and that would mean that each number will be represented once on diagonal 1. And let's add diagonal 2 at the same time. There we go. Now this... Okay, that didn't work. It's still 100%, but I think the problem here is not the setup, but rather that we haven't turned on the particular constraint. Limit busy times, we have to turn this on. And yeah, we've got some problems there, so look at that. Limit busy times on diagonal 2. There are 2 4s, and on diagonal 1 there's not a single 4. So we're gonna have to optimize this again. I'm going to turn off the display of the constraint breaks so that our display is nicer. So it didn't take a second like before, but it's taking some more time to actually optimize this whole matrix. It's done. So this is a valid Sudoku matrix. This is a valid Sudoku. But what we want to do is solve a Sudoku that is in the newspaper. And how should we go about doing that? So I found a hard Sudoku on a certain website, and I'm going to pre-create a timetable with all the numbers there and see if Skolaris can solve it for us. So let's create a new timetable, and it will be empty. And I'm just going to copy in the numbers and lock them in place. So this is a hard Sudoku solution, let's call it. I believe Skolaris will be able to solve it. So let's see, there is a 5 and 7. There is a 6 here and an 8, a 6 and an 8. Now let's lock all the visible lessons. Well, these are preset. These are required to stay in place, and save this. Now I don't know, because I don't play Sudoku myself, I don't know how they are classified to these easy, medium and hard categories. But let's see if this is hard for Skolaris to solve. And action. Okay. I can see what happened there. Let's just undo that. What I did when I chose lock all visible lessons, I actually locked these in unscheduled positions, which is not a valid thing to do. So Skolaris just placed them into the matrix randomly. And so let's unlock all lessons. And actually, how are we going to do this? Let's just log them one by one manually. It doesn't make sense to lock all visible lessons while there are unscheduled lessons when creating a timetable. So this is just a slight inconvenience that we're going to have to overcome when solving our Sudoku. And 3 more. There we go. So take number 2, action. Come on, Skolaris, you can do it. That's not over. That's not over. 20 seconds. Our fitness has to be 100% as well, because these are the daily booking for a course. So it has to be solved as well. So a feasible timetable could not be found. That is a disappointment. Let's try an easy Sudoku solution then. So let's put in the numbers. 4, 9, 6. That's all of them. Let's run this. Take 1, action. So from the machine perspective, this doesn't look like it's actually easier to solve than the hard one. That is that's interesting. Yeah, we couldn't solve it. So what could be the problem? So let's say we're going to use different values for time taboo search, because the number of lessons is only 81, which is extremely low. So we're actually going to use just taboo list of 5 to 10 with short-term taboo size of 1. And let's increase the number of steps to 5,000. And dynamic adaptation threshold, let's leave that the same. Actually, I gotta turn off interleaving as well. Let's see if that helps. Yeah, that is definitely helping. So we've only 7 problems to resolve here. So that didn't work. 5 minutes, and the result is we have 7 problems that haven't been solved. It's hard to say what the problem exactly is, but we're going to try to unlock these numbers gradually to see at which point Skolaris will be able to give us a solution. So let's try unlocking this one, and these guys. And let's go back to some faster optimization settings. So 500,000 steps here and 2,500 steps here and 1,000 steps here. Let's go. Look at that. Unlocking 4 has helped, and we're down to 5 problems. Down to 4. Okay, down to 2 problems. Let's unlock one more. Let's unlock this one. See if that helps. Didn't help either. So that didn't work. And let's try one last Sudoku, which is a medium one. Medium Sudoku solution. So there is a 7, 4, and save. I'm actually going to clone this so as not to lose the initial setup. Let's work on the clone and try to see if Skolaris can save some of its glory. Let's see what happens. That looks good. And there you go. Skolaris solved this Sudoku in 11 seconds. So there we go. I really don't know what's different in this one from the other 2 ones that we showed. But yeah, at least we showed that Skolaris is capable of, first of all, configuration that allows for generating valid Sudoku combinations, and it is also able to solve Sudoku, maybe not every time, but as this example showed, sometimes it is really easy. Well, let's go to that hard. No, we actually lost the hard one because I was unlocking some of those lessons. Actually, let's try to run the medium one again. See if something different happens. So this is the medium one. And we're starting from 3%. Let's run this once more. Yeah, this time it took slightly more time, but we got the solution pretty quickly. Let's go back to the easy one. I can't believe that there could be such differences. The problem could be that there are so many locked lessons. Skolaris works best if you let it do its job and not lock stuff in, but that is the nature of Sudoku. It tries to help you but by giving advice where these numbers should be. But in Skolaris' case, this could exactly work against the nature of the algorithm. So in our medium case, there were fewer locked lessons which could be the reason why Skolaris was able to solve it really quickly and really easily, and it is actually struggling with this one. Let's try to clone this easy solution. And clear scheduled lessons. Yep. So this is the task at hand. And let's delete this one. And I'm actually going to rename this clone to the original. And just like that. And clone this. And we can delete one of these clones. And let's see. Let's work on this easy Sudoku one more time. And take 25 action. No luck. The thing to take away here is don't lock your lessons in place. Skolaris won't be able to solve your timetable. And if you want to use Skolaris to solve Sudoku, choose a medium difficulty, because that's what Skolaris could do for us quite easily. Thanks for watching this lengthy episode. I hope you enjoyed this as much as I did, and I'll see you next time. Thank you very much for watching. Have a nice day. Bye.